Hello, I'm Ray, the Ray in the Ray Code. In this video, I'll be studying the design pattern known as Abstract Factory, and I'll be using PHP. Now, I use other programming languages to study this design pattern. For example, I use C#, Java, C++, but for this video, I'll be using PHP. Please check out those videos. Now, for this video, I provided a list of reasons why a PHP programmer will want to study this design pattern. We go through a sample code that you may find and play around with yourself, because I post that code at my GitHub site, also theraycode.org. I also provide a SWOT analysis for this design pattern. Now, I have put timestamps in the margin so you can navigate to the section that interests you most. Please follow me on Facebook, X, and LinkedIn. Leave a comment, subscribe, and tell a friend. The Ray Code is awesome. Here are some reasons for a PHP programmer to learn the Abstract Factory design pattern. Enhanced flexibility enables easy switching between different object families without altering the client code. Consistent object creation ensures all related objects are created consistently, reducing potential mismatch and errors. Code reusability promotes code reuse by encapsulating object creation logic in a single maintainable place. Separation of concerns separates object creation from business logic, leading to cleaner and more organized code. Easier maintenance simplifies maintenance by localizing changes in one place when modifying object creation. Improved testability makes unit testing easier by allowing the injection of mock or stub objects. Supports scalability facilitates scalable applications by enabling the addition of new product families with minimal changes. UML Abstract Factory declares an interface for operations that create abstract product objects. Concrete Factory implements the operation to create concrete product objects. Abstract Product declares an interface for a type of product object. Concrete Product defines a product object to be created by the corresponding Concrete Factory. Client uses only interfaces declared by Abstract Factory and Abstract Product classes. Collaborations. Normally, a single instance of a Concrete Factory class is created at runtime. This Concrete Factory creates product objects having a particular implementation. To create different product objects, clients should use different Concrete Factory. Abstract Factory defines creation of product objects to its Concrete Factory subclass. Hello, I'm Ray, the Ray in the Ray Code. In this video, I plan to give you an example of the Abstract Factory design pattern using PHP. The Abstract Factory design pattern is a creational design pattern. We start by creating an interface I call Abstract Product A. Abstract Product A defines an interface for a type of product object. We will require a function named UseFunction A. Next, we will create another interface we call Abstract Product B. This interface will be like Abstract Product A interface. We will require the user of this interface to have a UseFunction B, in which we can pass in a Abstract Product A type. Now, let's create the products. We start with Product A1, which is implemented by the Abstract Product A interface. So we require the Abstract Product A at the top, and for the UseFunction A, we return the result of Product A1. Let's add another class we call Product A2. We implement the Abstract Product A again. So the class, we implement the Abstract Product A interface, and for UseFunction A, we return the result of Product A2. Next, we create another product, this time using the Abstract Product B interface. We create the Product B1 with the Abstract Product B interface. We require once both Abstract Product A and B. We also add the method requirements UseFunction B and another UseFunction B. For UseFunction B, we return the string, the result of product B1. And for the other UseFunction B, we return the result of B1 collaborating with an object of type Abstract Product A. Let's create another product that implements Abstract Product B. Class Product B1 implements Abstract Product B, and as such is required to have UseFunction B and another UseFunction B methods. At the top, we require once Abstract Product A and Abstract Product B interfaces. For UseFunction B, we return the result of product B2. And for another UseFunction B, the result of B2 collaborating with the Abstract Product A object that just passed in. We create an interface we call Abstract Factory. The user of this interface must have create product A and create product B methods. Now let's create a Concrete Factory we call Concrete Factory 1. Concrete Factory 1 will be implemented by Abstract Factory, and as such must have a create product A and a create product B. At the top, we require once Abstract Factory, and also we require once products A1 and B1. For create product A, we return a new product A1. And for create product B, we return a new product B1. We create another Concrete Factory, this time Concrete Factory 2, and it too is implemented by the Abstract Factory. Because it's implemented by the Abstract Factory, we need to have both create product A and create product B. At the top, we require once Abstract Factory, also require once product A2, and require once product B2. For create product A, we return a new product A2 and a new product B2. Now let's create a client for our project. We have the client class. At the top, we require once Abstract Factory. We have two private variables, product A and product B. We create products A and B by the create product methods on A and B. We set up our run methods, create product A, and we pass a product A object into another UseFunction B. So let's now go to the index to complete our demo. We require once Concrete Factory 1 and Concrete Factory 2, and we also require once the client. Now for our main method. First, we echo testing with Concrete Factory 1 and set Factory 1 to a new Concrete Factory 1 client and a new client in which we pass in a Factory 1 and run. We do the same for a new Concrete Factory 2 object, and we run the main method and we get testing with Concrete Factory 1 the results of product B1. The results of product B1 collaborating with the results of product A1. testing with concrete factory 2 the results of project B2, the results of project B2 collaborating with the results of project A2. This output demonstrates that the clear can work with any factory creating different products and using their methods interchangeably. My name is Ray. Keep coding. SWOT analysis of the creational design pattern known as abstract factory using PHP. S. Strength. Consistency. Provides a consistent interface for creating related objects without specifying their concrete class. Flexibility. Enhances flexibility by allowing substitution of an entire family of products in PHP projects. W. Weakness. Complexity. Can't introduce unnecessary complexity by requiring additional classes for every product variation. Learning curve. Requires a steeper learning curve, especially for beginners in PHP due to abstract concepts. O. Opportunities. Scalability. Offers opportunities to scale applications by adding new products without modifying existing code. Cross-platform. Facilitates the creation of cross-platform PHP applications, enhancing market reach and adaptability. T. Threats. Over-engineering. Risk of over-engineering in simple PHP projects where a straightforward solution might be sufficient. Performance impact. May introduce performance impact due to extra layers of abstraction in PHP applications. That was my video. I plan to create these videos each week. Follow me on Facebook, X, and LinkedIn. Check out theraycode.org and .com. Leave a comment, subscribe, and like. Be good. The Ray Code is awesome.